Okay, so we'll look at transformations today. As an introduction, let's look at this example where we've got to work out the equation form y equals ax squared plus bx plus c. Okay, for the first one, in completed square form, what would that be? Anyone? Wisdom? X minus 1 squared minus 2. Excellent. If you expand that out, has anyone expanded that out? What do you get?
X squared
Yeah.
minus 2x
Yeah.
minus 1.
Excellent. Okay, so there's our quadratic. What about for the next one, the minimum? Sam?
X plus 3 squared plus 1.
X plus 3 squared plus 1. Has anyone expanded that out?
X squared
Yeah.
plus 6x
Yeah.
plus 10.
Plus 10. Excellent. And not last but not least, the last one here. Sia?
X plus 4 minus 4 squared
Yeah.
plus 3.
Plus 3. Okay. Now, because we have to be a bit careful here, because it's a maximum point, okay, what we'll need to do is in fact put a minus sign outside over here. So it'll be a minus x minus 4 squared, and that 3 will remain positive. Okay, and that's because it's a maximum, so it will be a sad shape. And then we can expand that out. Has anyone managed to do that? If you expand it out, we should just get minus x squared plus 8x take away 13. Alright, so there's our vertex, and we know when we sketch a quadratic, in terms of sketching quadratics, there's a couple of points. Number one is a greater than 0. It's going to be a happy shape. Obviously, if a is less than 0, you'll be sad shape. Number 2, when x equals 0, what do you get for y? And number 3, when y equals 0, what do you get for x? And those are the essential 3 points you need for sketching quadratic. To work out the vertex is just a bonus. And I'll just put down here, we also know for the vertex, does anyone know the equation of the vertex? If you don't want to complete the square? Minus b. Okay, I'll write down the x coordinate of the vertex is minus b over, can you remember? Minus b over 2a. And that's a little useful thing to know, because sometimes you might not want to go through trouble completing a square on a quadratic. All you want is a line of symmetry, okay, which obviously runs through the vertex. Okay, so the equation of the line of symmetry will obviously run through the vertex. What I like to do is take the first example where y equals x minus 1 squared take away 2, draw a little sketch, and then start playing around with that on GeoGebra. So let me just put that in GeoGebra, which is here. Okay, and let's put in f of x equals x minus 1 all squared. Okay, and let's put a squared in. And minus 2, is that right? Was it minus 2? It was minus 2, isn't it? Yeah, so x minus 1 all squared minus 2. So here it is. And we can see the line of symmetry is going to run through minus x plus 1. Yeah, so if you put in x equals 1, okay, there's your line of symmetry. Okay, and there's your vertex, it's your minimum point. Okay, in fact, what I could do is, just as sort of some notes, we could just bring this in over here. So if anyone's looking at it later on, oops, let's go back. Okay, there you go. Alright, so let's just write this down. So here's my little sketch of f of x, which is x minus 1 all squared take away 1, and then we know this vertex's minimum is 1 minus 1, so that's minus 2, yeah, minus 2, yeah, minus 2, and the equation of the line of symmetry is simply x equals 1. and that's my fx. Okay, is that okay for everyone? Right, and what I'll do here on this side, what we're going to do is now have a little play around. So I'll do f of x. In fact, yeah, let's do that. Let's make a little table and get a straight line and do something like that, and then do something like this. Okay, and over here, in fact, we can get rid of that line, and let's just put down the vertex. And what we'll do is start moving fx around, start doing some transformations on fx, and see what happens to the vertex. So the vertex we've got at the moment is -1, -2. Agree? Okay. Sorry, 1 minus 2. Okay. All right. Let's take fx now. Let's get rid of this line. Let's take fx. Okay. And let's do +1. What's going to happen? It's going to move up. So which coordinate is going to get affected? The y coordinate. So this point here, if I just put a point on the object over here, and if I can do show label, let me see if I can get the label up and running. Yeah, name and value, that should be good. Okay, and now I have it. I've got 1 minus 2. Now this gets shifted directly upwards. Okay, so this now goes to this point here, 1 minus 1. So therefore, if we've got, so to fill in our table, if we've got f of x plus 1, the x coordinate stays the same, the y coordinate goes up by 1. Agreed? Alright, let's now go back to our GeoGebra, and in fact I can get rid of the red one. What if I had, let's get rid of that as well. What if I had this, f of x plus 1 inside the bracket? What's that going to do? Goes left, so it's counterintuitive, yeah? Plus, you would think it would go right, yeah, because the x-axis increases towards the right, but in fact it goes towards the left. So my new coordinate would now be, let's write this down, f of x plus 1, it moves to the right. So what changes? Does my y coordinate change? The x changes, it becomes 0. Okay. Alright, so we've got those translations. What if we did f of x plus 1 plus 1? Less than up? Okay, so we'll have 0 and minus 1. Okay, so we've got two translations. And it's not too bad. When you do C3, because at the moment we've done two translations, the x and the y. Okay? And they're two different ones, they're not going to affect each other. So if you do the y first and then you do the x, or you do the x or the y, it doesn't really matter. You still get the same thing. But there's certain combinations which we don't really do in C1, probably do it in C3, where the order will matter. Now let's also do, in terms of, so these are translations, they basically just move your function up and down. Let's also now do stretching. Let's look at what happens if you put a minus inside the bracket. Okay, so if I do, here it is, let me get rid of that. If I do f of minus x inside the bracket, that's a reflection in which axis? The y-axis, right? So let's just put this down. So I'll just put down reflection in y. And if 1 minus 2 gets reflected in y, which coordinate gets changed? If it gets reflected in y, and what does it become? Minus 1 minus 2? Okay, so we therefore get minus 1 minus 2. Yeah, and we can see that from here. The 1 minus 2 has now become, if I was to put a dot on this, has now become minus 1 minus 2. So it's got reflected in the y-axis. Is that okay? Alright. Let's get rid of this dot. Let's get rid of that. Now, what if I did a minus outside the fx? What's that going to do? Yes. Right, and then what happens to the coordinate 1 minus 2?
Goes mine. Wait, no, 1, 2.
1, 2. Yeah, you're right. 1, 2, and you can see over here you get 1, 2. Okay, so let's put that in as part of our notes. So you got minus f of x, and our vertex now becomes 1, 2. Capiche? Alright, let's just extend this just for 2 more points, which are really basically the same thing. So these are translations over here. I'll just write down translations, and over here we've got stretches. Alright, what if, let's go back and let's turn this off. What if I've got f of 2x? What's that going to do? Yeah, somebody else. F of 2x. It's going to be a stretch in which axis? Stretch in which axis? See here. Okay, but what scale factor? Half. Right. So what's going to happen? Which coordinate will get affected? X or y? X. What will happen to the x? Yeah. So the 1 becomes 1 times a half, and there we have it. So that 1. Yeah. So all my x values have shrunk, and so that coordinate now, let's just check. If I just put that on it, has now become. If I just move this around, is now goes to a half. Okay, so therefore f of 2x, okay, gives me a half of 2, and it's a stretch in the x-axis by scale factor 1/2. Now, in an exam, and I've recently just marked a C3 exam, this is a 2-mark question. To explain what f2x does, it will be 2 marks. One for saying it's a stretch in the x-axis, and the other one for saying it's actually a scale factor of 1/2. And you need to be very specific about keywords like scale factor and stretch, and in which direction this stretch is actually in. Very specific. Similarly, if I did 2fx, that would be a stretch in which axis? Y-axis. So if I did 2f of x, and then what happens to the 1, 2 coordinate, Derek? The 1 minus 2 becomes? Uh, 1 minus 4, yeah? So the y coordinate gets multiplied. Okay, so we end up with 1 minus 4. Okay, and this is a stretch by scale factor 2 in the y-axis. Again, those key terms like stretch, scale factor, in which direction is very important when you're talking about the effect of a stretch or transformation. Is that okay? So that's probably a bit of recap from GCSE. Now, needless to say, instead of writing the numbers 1 as I've done, or 2, I could have written just a letter, and you can generalize it. Yeah. So rather than doing fx plus 1, we could do fx plus a, and fx minus a, and f2, fax, fbx, etc. Okay, I'll leave that for you to do if you want to sort of put that in basic algebra terms. I've used specific numbers because obviously we're doing the examples on GeoGebra. Yeah, so I'll put in specific values. But we all started off with this vertex 1 minus 2, and then applied all these different transformations on it. Is that okay? Alright, so just to recap for some of the new things we've done today. We've just recapped our work with completed square form. We've looked at the vertex, so plus p plus q will give us a vertex of minus p and q. In the example where it's actually a maximum, we've got to make sure we put the minus sign outside. We can obviously expand these out. Needless to say, if you've got a quadratic, you can complete the square. But if you're just looking for the line of symmetry or the vertex, you can just use this nice little neat formula, minus b over 2a. Okay. The 3 steps to sketching a quadratic is when a is greater than 0, it's happy. A is less than 0, it's sad. When x equals 0, work out what y is. When y equals 0, work out what x is. And then we've got these various transformations that we can apply. We can translate it, and maybe I should put that in actually. Maybe we can put that in as a side note. So when it's fx plus 1, it's a translation of 0, 1. Whereas f minus 1 is minus 1, f plus 1 is minus 1, 0 translation. And that would just be minus 1, 1. And obviously then you have a reflection in the y-axis, and this is a reflection in the x-axis. Okay, and then you've got these stretches. Is that okay? Any questions?
So the first one, 1 minus 1, so should it be 0 minus 1?
No. Because the y value has been affected. Yeah. F bracket what? 2x? Here? What don't you understand? Alright, so for the moment what we could do is take it as a general rule that when you've got a number inside the bracket, whether it's a 2 over here or it's a plus 1 over here, okay, then it does the opposite operation. Okay, so rather than stretch it by 2, it's going to stretch it by a half. Over here, rather than move to the right by 2, it's going to move to the left by, so rather than move to the right by 1, it's going to move to the left by 1. But essentially, things that are inside the bracket, and you'll probably see more of this when you do C3, behave in the opposite way to BODMAS. And it's to do with the order of operations that occur in order to set up a function like this. Okay, so if you start with fx, how do you generate f2x? Now, it'll be easier for you to understand that if you do multiple operations on something. So if you do f bracket 2x plus 6, for example, and you think, what sort of combinations can I do to get that? But then that takes you more into C3. But I would say for the moment, if you can possibly just be content with saying that when it's inside the bracket, it's always the opposite, yeah. Okay. All right, let's go with some questions then. I'll bring the recording to a stop and I'll